Okay, so we've talked about elements, so now we're going to be talking about compounds, which is one of our substances that we have that involves more than one element a lot of times. Two or more elements that are chemically combined. So you have um, multiple elements. It can be anywhere from two to, you can go all the way up 5, 7, 8. Obviously you there tends to cap out at a certain point, but two or three is pretty common to have. So they are actually bonded together. They're not something that you can easily pull apart because they are chemically combined. Uh, the way this happens is these elements are going to react together, a chemical change happens, and they become a new substance. So they form this compound. So remember we said that chemical changes, for one, form a completely new substance, and that when they happen, they're not easily reversed. So they become this thing that is bonded together that is not very easily separated. Now, one particle of a certain compound is called a molecule. Not not all particles are called molecules, but for now, for simplicity's sake, we're gonna say that they're all called a molecule. So, um, again, are formed when we have our multiple atoms of our elements joining together. One important thing to remember, because we're going to be getting into talking about mixtures later, so this is something we will compare and contrast with compounds and mixtures, is that elements do not just randomly form compounds. You're not going to randomly sometimes have one sulfur and two oxygen atoms joined together, and then the next time it's going to be four sulfur and nine oxygen joined together. And if that happens, they're not going to be the same compound. They are going to only join in a way that the chemical bonds allow them to, which is something we will get into more detail in later at the end of the semester. But just know that they're going to form in specific ratios based on the electrons in that atom. They're not going to just join together randomly, because if they do, if they can join together in a different way, it's going to be a completely different compound. And they have physical properties. One thing to remember is that the compound itself is going to more than likely have different properties than the compound or than the elements that make up that compound. So a really big example of this is table salt. If you did not know, table salt has a sorry, what am I looking for? Oh, a scientific name is sodium chloride. So sodium chloride is written as NaCl, so because it has one atom of sodium and one atom of chlorine. While I'm thinking of it, for extra credit, to see who's listening to my video, I want you to write NaCl right next to the section that the slide goes with. So I will check to make sure you are listening. But anyways, back to sodium and chlorine. Sodium by itself is a extremely volatile element. If you put it in water, it explodes. We're going to be looking at stuff that later in the semester, but it's extremely explosive and reactive to water. Chlorine, existing by itself as a gas, is extremely toxic to people. If you put chlorine gas, they've used chlorine gas to try to clear crowds and riots. So apart, these two elements they're pretty dangerous. But then we put them together, they form as a chemical compound. Once they're combined, they form something that people eat on a daily basis. So those properties of compounds and the elements that make them up, they're more than likely going to be different. Breaking down the compounds are not very easy, but some compounds it can be done with. Because remember, it is a chemical change has happened, so reversing it is not super easy. But if you want to do that, a lot of times energy is going to have to be applied. So you can be applied as heat, can be applied as electricity, but sometimes a compound can break down into a simpler compound. Sometimes you can break it down into the elements itself that make it up, but either way, it's not going to be a super easy task for that to happen. And there are compounds everywhere around us. There are so many compounds that we need to survive, let alone things that we just use on a daily basis that we have created or we have taken from nature to use to our advantage. So, one thing about the compounds you find in nature is a lot of times those materials that we are using from those compounds, we separate from the compound it came from. So aluminum is a big example of this. When there's not just free aluminum out there that people are mining, a lot of times the most common compound that they are mining is called bauxite, and then they extract the aluminum from that. So they are able to separate. They use a process to separate that compound and make it into just aluminum by itself. So a lot of things, raw materials we use exist as compounds, and then we take that element out from there. But there's a lot of compounds out there that we use as the compound itself. Um, Two that we absolutely need are proteins, which are made up a lot of carbon and hydrogen and nitrogen, and then possibly some other elements, and then carbon dioxide. And we definitely need that in our lives. Obviously, we breathe out carbon dioxide. Oxygen gas exists as a compound. That's something that's necessary. Water is a compound. So there's just so many things out there that exist as compounds that we are using, whereas free elements are a little harder to find. But we will get into talking about the compounds versus mixtures, and you'll definitely find that compounds are something that you find more in nature and that become more useful to us.